Okay, so I'm going to duplicate or do what we did in class with the transformer experiment. And I'm told I got sound issues, so I'm going to be using the headphones. I don't think they'll get in the way. And let me bring in the lab. So there's the first part of that, first of 2 pages. And basically we're just going to set up an oscilloscope, a simple little transformer, which I'll show you. They're small, and our picoscope for a signal generator here. All right, so I'm going to take a moment and set that up, and then we'll do the experiment. Okay, so here is our transformer, and I've got 2 leads over here, the yellow leads. That's just like these 2 leads here. And I've got 1, 2, 3 leads coming out the other side. The white one is number 2, and the red, I can call that number 1, and the orange one number 3. The 1 and 3 can be reversed in a center tap type transformer, which this is. Now, we got our, I'm going to bring up the picoscope. We're going to need that. And here it is. If we can get this to cooperate tonight. So this little guy here, this is the connection to the noise, not the noise, the signal generator. And this blue line is trace number 1. So I'm going to connect that as input and output. So here I'll put the blue line on the input, and you can plug them in either way. The biggest thing is making sure they stick to the wires and the wires don't touch. Okay, so I'll take trace 1 in the usual way, and I'm just going to match these 2 so we can see what's happening on that input. Okay, this is the thing where we've got this very nice Pico instrument here. Whoops, here, that has oscilloscope and signal generator built into one. So now I'll go up. This is that signal, and nothing's showing up because there's nothing coming on. I'm going to turn it to AC. And rather than just let it take off, I know that it's no more than plus and minus 2 volts. So there's that scale. And now let's set up the signal generator. So here it's set for a square wave. Let's change that to a sine wave. And the specification was for 2 volts and 100 hertz. So I have a kilohertz, so I'm going to turn this way down to 100 hertz, and I'll turn that up to 2 volts and turn it on. Whoa, it's wobbling all over. So apparently we've got a real low frequency. Here we go. Now we can see a few of them, and remember the one other thing we'll have to do here is turn on, there's no trigger, it says none, so we'll turn on a trigger and stop the scope. I'll put this over here. Alright, so now we can see everything that's important. And one thing I can do then, the obvious next thing, is just to take the remaining signal. I got to find that wire. Here it is, coming off of the B channel, and I'm going to hook it up. What does it ask me for here? I can look at these real close. It's going to want to know what's the RMS voltage of this source. Well, now we're not going to get that off of an oscilloscope. Maybe a real fancy one. This is pretty fancy, but I haven't been able to find an RMS measurement there. There probably is one. But I can use the ever trusty multimeter for that, right? I can bring a multimeter into the picture. So maybe if I set that over here, if I'm lucky enough, I'll get this to pull out and fit in. So it can hold it so the you guys can see the actual scope. All right, now it's voltage, so I don't have to open up the wires. I'm not measuring current. So if I turn this on, this is this new type of multimeter. So I've turned it on to volts. Maybe I can use one of these as a pointer. And right now I'm looking at volts DC, it says. So I got to select volts AC. You see what happened here? That turned from DC to AC. Now I'm just going to take the two probes and put right across the input to the transformer. This is a little bitty transformer, not like the kind you see out on the poles. And what are we seeing here for an RMS value? 1.394, right? So you can write that into the lab, 1.394. Now you might remember that that the RMS value is the peak value divided by the square root of 2, or it's the peak value times 1.414. Hey, all right, hang on. I think I'm going to, well, I thought I could get a pen that could write over this, but I don't think so. So if I take 2 volts and multiply it by 0.707, I get 1.414. So we almost got that. We got 1.394, just a touch off. So at any rate, that's the RMS value. Now we're going to go down here. They want peak values and the frequency measured by the scope. Right? So the scope has, follow my pointer, I'm over here at 1 millisecond per division. So every one of these divisions then, oh, it looks like it's times millisecond. So every one of these is 2 milliseconds. So let's just find 2 points. Here's a zero crossing, and I've got 1, 2, 3, 4, 5 divisions at 2 milliseconds per division. That's what it says up here. 2 milliseconds per division times 5 is 10 milliseconds. Right? So that means the length of one cycle, one period we learned last week, is 5 times 2 is 10 milliseconds. So that's the period. 1 over 10 milliseconds is the frequency. So if I divide 1 divided by 10, I get 0.1, but then I would have to multiply it by 1 over 1 millisecond. That's 10 to the minus third. So you can do that math. I end up with 100 hertz, which is just what I set up here. So that's the frequency, and we verified that on the scope, right? So you can't see my finger there. This frequency is this frequency, and we verified that on the scope. There's one period. Now all we have to do is measure the voltages at the output points 1, 2, and 3. So I'm just going to designate one of these. Whoops, I don't want the multimeter. Get it out of here. I'm just going to designate one of these, and we're going to turn this on. So I'm going to put 1 and 3 and 1 and 2. So I'll designate one of these as a ground and just put the black lead there. And it looks like it wants 1 and 2 first. So I've connected it between one side and the center. Now let me turn on another, I'll turn it on to 2 volts also. Oh, here it comes on. I'll make it AC. Okay, so there's the signal coming out of these 2 points, 1 and 2. And what's the value of it? Now that signal is in red, so the value of it is over here on the right-hand side. And it looks like it's peaking out at about 0.4 volts. Right? So I'll just mark that. It looks like 414 millivolts. 414. So 0.414 volts. That's this value right here, 0.414 volts. Now we want the volts between 1 and 3, so all I have to do is take the red connector and move it over to the number 3 lead. Oh look, things got bigger, the same shape, but things got bigger. Okay, so almost twice as big, 0.8 instead of 0.4. Yeah, 0.8 instead of 0.4. So this value is 0.8 volts. This one was 0.4. All right, so now we've done the measurements. You can answer these questions yourself then. What's the ratio of these 2 voltages? And that means these two right here. These 2 voltages, V12 and V13. Actually, no, that's not what I want to say. I want the ratio. I led you wrong. What's the rate? I led you wrong. It wants to know, we're looking at 2 channels. That's the 2 we've got right here on the screen. To display V1, V1 is in blue, and another one to display V13, which is what we have in red. There's V1 on the input, and there's V13 on the output of the transformer. So these are the 2 voltages they're asking. What's the ratio of these 2? And we will take it as the ratio of V13 divided by V1. So we're taking the ratio of this value, 0.8, divided by this value, which is 2. Okay, so 0.8 divided by 2, that's the ratio you want to put here. Now it asks, are these 2 voltages in phase or out of phase? And you can see straight away from the picture, they are out of phase. When the input goes positive, the output goes negative. And vice versa. When the output goes negative, the input goes positive. So they are out of phase. But that was strictly a matter of how we happen to hook up the oscilloscope. Just for fun, let's reverse the 2 oscilloscope leads. Oh, and now they look in phase. Okay, so it's simply a matter of how we hooked them up. So when we reverse them, whatever we had here for this answer, which was out of phase, they're now in phase. Okay? Kind of straightforward. The phase relationship is important in some situations. And in housing, it can be definitely there between the two sides of, say, a 240 volt appliance setup. Okay, so this is all the information, the measurements you need to do part 1. So I'll stop at this. And again, if you have questions, you can call me, email me, whatever. But do finish this part, and I'm going to do a second lecture that contains part 2, which is just a little bit of fun with this, where we make some more measurements and draw a picture.